This is an introduction to sets. We're going to talk about roster notation, set builder notation, and also interval notation. So first of all, what is a set? A set is basically just a collection of items called elements. And those elements, when we write them within the set brackets, and you can see what the set brackets look like here, when we write them in the set brackets, we always write them in numerical order if they are in fact numerical values. You can also have a set of categorical data, like the set of the primary colors, in which case the order that you wrote them wouldn't really matter. Here we have an example of write the set of the first 5 even numbers, so that would be 2, 4, 6, 8, and 10. Notice that each of the elements is separated by a comma, and that there's a set bracket on each side. So if we were asked to then write the set of the first 6 letters of the alphabet, we would write A, comma, B, comma, C, comma, D, comma, E, comma, and F. And then I would close the bracket. So again, we're looking at those squiggly bracket signs that let me know that it is a set. The way that we are writing these is called roster notation. So just like if you're a sports fan and you have a sports roster, it's a listing of all of the players on the team. Roster notation is a listing of all of the elements in the set. As I said, typically from least to greatest if you're dealing with numerical data. Another way that you can depict the items in the set is by set builder notation. And set builder notation is different than roster notation because we're not actually going to list the items. We're going to describe what the elements in the set are. So the first part here is you're always going to write X or whatever your variable is. Typically we use X. This means such that, so this is the set of all X's such that, and then this is a description of anything in that set. So X is a vowel in the English alphabet. So this would be roster notation, A, E, I, O, U, the vowels. To write that in set builder notation, you're going to write it as a description for the second part of that. Here are a couple of practice for you. First, convert the following to roster notation. So I have all of the X's, the set of all X's, such that X is an odd integer and between -2 and 11. So first let's notice that here this is not an or equal to, and so I'm not going to include the number -2, but I'm looking for all of the odds between -2 and 11. So if I'm writing it in roster notation, I'm still going to use my set bracket. I'm not going to use -2. I am going to use -1 because it's odd and it's an integer meaning a positive or negative whole number. I'm not going to include 0 because it's not odd or even. I will include 1. I will include 3 and 5 and 7 and 9. I won't include 11 because there's no or equal to on this one. So that is how I would write it in roster notation. My second one is going backwards. So it's going from roster notation to set builder notation. So again, I'm going to use set C equals the set of all X's such that, and then you can either write it in words or basically you're just going to have to describe these in a way that would make sense here. So what I'm seeing is that I've got multiples of 4, and there's different ways to write this. We're going to use the very, very simple way. There is a more complex mathematical way. We're not going to worry about that in this case. So I'm going to say 4 is between, X is between 4 and 24, and that X is a multiple of 4. That's one way to write it. I could have said all of the X's such that X is a multiple of 4, less than 24. So it's kind of up to you. Set builder notation is used quite often. Again, there is a more complicated way to write that, but we don't need to worry about it in this case. Interval notation is one I really want you to get used to because you're going to use this a lot. But interval notation is used when the numbers are continuous, which means I wouldn't be able to actually list all of the numbers like 1, 2, 3, 4, 5 because it would include like 1.2 and 1.22 and 1.222. So that would not be, feasible for us to actually write them out in a roster notation. So interval notation is when it's continuous and it's, say, between two numbers or greater than a number, etc. So my example here is that x is greater than 3. So we're saying any number that is bigger than 3, like 3.000001, is okay. We're always going to write them, and this is very important. You always write them from left to right, least to greatest, and you use a comma in the middle. Now here, we're going to use parentheses. So on our last example, when we did roster notation, we did the set brackets on each side. So when you use interval notation, you're either going to include parentheses, and those parentheses say that the endpoint is not part of a set. So here, if I'm looking at x is greater than 3, 3 is not part of that set. So I'd have to do a parenthesis 3, comma, and I'll get to that second part in just a minute. If it were included, I would then use the brackets instead, but notice these are still not the set brackets. These are closed brackets, okay? So here, parentheses are always used with infinity or negative infinity, and that's what I'm going to use up here for my x is greater than 3, because anything greater than 3 all the way up to infinity is included. So I would write x is greater than 3 as open parenthesis 3, comma, infinity. This table is a really great reference for you, so it might be a good idea to go ahead and print this one out. But I just want you to see the differences between the graphs and the notations here. Notice here, if I have a to infinity, that's going to be that open bracket going on to infinity with an arrow on the end. If I go to negative infinity, obviously it's going the other direction. Notice every interval notation goes from least to greatest. Let's see, this is a completely open interval because each side is open, so it has the open brackets or parentheses. Over here we have a closed interval. This is the closed bracket, meaning that a and b are included in the set of values. So you can kind of see what some of the different graphs and interval notation, how they relate to each other. So here's what we're going to do. We've got a few in set builder notation, and we're going to write them in interval notation for practice, and then we're going to look at their graphs. So looking at my first one, I have all of the x's greater than 3, so we kind of cheated and did this on the other screen. I'm looking at not including 3, so that's the open parenthesis, and then everything greater than that is infinity. So if I'm going to graph that, I'm going to find 3, I'm going to put the parenthesis, and then I'm going to shade everything to the right of that and stick an arrow on the end. Let's look at all of the x's such that x is less than or equal to 1/2. So now I'm looking at less than or equal to. So I'm looking at negative infinity here, because it's going to go on forever in the negative direction, but it's going to stop at 1/2, and it will include 1/2 because of this or equal to. So 1/2 is part of my solution. So I'm going to find 1/2, which is halfway between 0 and 1. I'm going to put my bracket here, and then I'm going to shade to the left. And of course, stick an arrow on the end because it goes forever in the negative direction. Last one here, I've got -2 is less than or equal to x is less than or equal to 4. And an interval notation, notice these are both or equal to's. That means closed bracket, -2, comma, 4, closed bracket, because they're both included. So at -2 and at 4, and I'm shading in between because this means all of the numbers between -2 and 4. Here are a few questions for you to try on your own, so try them first and then press play and see how you did. Looking at my first example, I have x, all of the x's such that x is greater than -8. So I know that I'm starting at -8 and I'm doing any number that is greater than that, which means -8 not included because it's a greater than and not a greater than or equal to, all the way up to infinity, and remember infinity will always be an open bracket and never a closed bracket. On my graph, I'm going to go to -8 and put a parenthesis, and then I'm going to shade everything that's greater than that, or everything to the right of that. For my second one, all of the x's such that x is less than or equal to 6.5. So here I've got anything less than, which means it's never going to stop. It's going to go on to negative infinity, and then to 6.5, and 6.5 is included because of the or equal to. Again, make sure that you are paying very close attention to the order. So it's important that I have that negative infinity first because that's the one further to the left. So as I'm graphing them on here, they should be in the same order, that as I'm writing them in the interval notation. So negative infinity isn't a real number, but we know that negative infinity is down in this direction. So notice it's negative infinity and then 6.5, which is going to be a bracket, and I'm shading in between those values. So this arrow indicates, yes, it's going to keep going forever in the negative direction. And my last one here I have between -5 and 3. Now notice on the left side of this one, -5 is included, but on the right side, 3 not included. So at -5, I've got the bracket. At +3, I've got the parenthesis, and all of the numbers in between there would be in that interval.